If you are if you have always been interested in the petroleum engineering industry, specifically you've always wanted to be a drill engineer, you're welcome to the right channel. If you have been in the petroleum industry, you're an experienced professional and you have a lot of questions, unanswered questions with regards to the drilling operations and perhaps the way wells are executed, the way wells are constructed, you're welcome to the right channel. My name is Ugo Koli. I'm a well engineer. I've been in industry for circa 12 to 13 years, but I've been very opportune to drill wells in all terrains, from land, shallow water, deep water. I've been on the semi-submersible, I've been on drill ship, I've been on swamp rigs, I've been on land rigs, and I've been opportune to see these wells execute them myself. So you're welcome to this channel. On this channel, we'll be sharing a lot of information. We'll be having a lot of teachings. So we will need a lot of feedback from you to be able to make this channel more like to subscribe. It is only when you subscribe that we're able to that you're able to know when we share a new video, and it's only when you welcome to our maiden video. And on this presentation, we'll be sharing with you the well construction process. um the outline is pretty much what you see on here. We'll be talking about how to design, how to execute a well, but we'll be taking it all the way back from the rig positioning down to the well completions. So this is pretty much what the outline looks like. We've looked at the prototype well drilled here in Niger Delta, and that's what we're going to be using. The sequence is what we're using to run through the well construction process. What you see on this next slide is a rig being taken to location. But ladies and gentlemen, I must tell you that before this happens, a lot of work has happened before this comes up. The well would have been mapped, it's been chosen, the well has been designed, and I mean it's been ascertained that this particular rig going to would have checked the drillability of the well, checked that this rig can actually deliver the well as per the hoisting system. We will have checked the hydraulics to see that the pumps here can actually deliver. We would have checked the well control system to be sure that the pressures that we're expecting, that this particular rig can handle these pressures. So before this rig gets to location, trust me, would have been able to confirm that this rig can actually drill this well. And not just that, would have checked the certification of this rig to be sure that all with regards to this rig, the all the systems, all the major systems, the power system, the hoisting system, the fluid, everything with regards to this rig is fully certified, so that it gets there and we don't have any reliability issues. So accepted. What do I mean by it's been accepted? Before we fully sign off to taking on the rig, we try to simulate a drilling operation, having the top driver at full speed, pumping at full speed, checking the engines to ensure that nothing trips off, that at those rates that this rig is functional, before we fully sign on to the rig contractor that, hey guys, we're pretty much good to go. Then it is positioned, I mean, at the well center where the conductor is going to be hammered and prior to the commencement of the drilling operations. So on this next slide, you see the conductor driving operations. Now, I must say that for optimization, sometimes this is done before the rig gets to location. Some people actually prefer, I mean, most people prefer to have these rigs, to have the conductor driven prior to the rig getting on location, so that once the rig comes on location, we have a final fix of that conductor. Then we'll just go ahead, pick up and clean the conductor. But here I just decided to talk through that sequence, having the rig on location before we drive the conductor. The hydraulic hammer, or rather the hammer, the diesel hammers, we bring up the hammer and we drive the conductor on depth. And after that is done, we pick up our first assembly to clean the conductor. So the conductor is clean to your left, let me just put up my pointer. So better, and go ahead to drill the surface hole section. Now, for this presentation, we've assumed that the surface hole is 17 and a half or a 16-inch hole. That will be drilled. And note that when that is done, we have a diverter nippled up. Now, the diverter is a piece of equipment that is being able to handle shallow gas in the event that shallow gas is one of the risks we're expecting while drilling this well. So when that happens, it's closed, then we divert the gas to surface through these lines. Why that is used is because it is expected that this shoe that you see here is not competent enough, because when you if you have the blowout preventers rigged up, when you close it, there is the propensity of you fracturing this shoe, or I mean messing up the hole that that you've been drilled. So what you're doing is closing and giving a leeway, giving a path for the fluid to be diverted out on surface. So that's very important. That's something you should, a very important part of drilling operations. You never rig up the BOP while drilling shallow sections. So after that is done, you now run your surface, you run it down to bottom and you cement it. Here you see a darker patch of cement we call the tail slurry. It's a competent shoe to be able to hold the structure of the well in place while we drill the next hole sections. And the light part you see here is the lead slurry that goes all the way to surface. Cement is expected to provide the hydraulic and structural isolation to keep the well bore in place, to ensure that the well bore it's firm. It's like building a house and expecting your house to have a firm foundation. So having the slurry come all the way to surface is ensuring that you have a firm construction, because the next thing that's going to be going on here, your casing head and your BOPs, and most especially will be carrying the rest of the strings and the completion equipment. So moving on to the next slide. Once that is done, once we have the here it is apt to have the BOP nippled up or have the BOP rigged up, because we know that the formation that we are going to be drilling through next is very competent and can handle it. We will. This is pre. Where if you can see my cursor, this is pre or while the well is being drilled, and to the right, this is after the well is being drilled with the drilling assembly pulled out of hole. Then on the next slide, we have run the integrity. But note that for this conversation, for this discussion, we have no hydrocarbon sands that we plan to isolate. So the 958 string run and cemented as per plan. Then after that is done, we have the hanger installed, and after we have the hanger installed, that's what you pretty much see on this slide. So this is what you have on the right. What you have on the left is a blowout of what you have on the right. So we have the casing cut, then you have the housing, the hanger installed. Then after that is done, after you have the casing hanger installed, then you have then after that is installed, you now install the blowout preventer on top of the spool. So it's all measured. It's all it's a control system all made up to ensure. Ensuring the same sizing and ensuring also the same pressure rating. So after that is installed, I forgot to mention, after every casing is installed, you install an annular seal, because when you have the casing installed, there will be an annular lap. So you install the seals to ensure that you have full isolation of that zone after you have the casing run. Then after this is done, you are now ready to drill the next whole section. Next whole section where we'll be drilling through the hydrocarbon sand. So what you see and then the different shade here is the hydrocarbon sand, and we'll have the 8.5-inch hole penetrating that sand. So this is the drilling operations going on, drilling through that sand. And what you see on the right is the BHA out of the well after that sand is being drilled. So post drilling through the sands, there are different scenarios or different ways where you can have these wells completed. On this slide, we have assumed a cased hole completion. Now, to define, there are two types of completion. You First completion is completing the sand where the reservoir is going to come from, ensuring that you have good sand control and you don't have sand coming to your well bore. Then you have your upper completion. That's the tubing string where the hydrocarbon will flow through. So before that is done, necessary designs would have been done, checking the porosity of the sand, checking the permeability of the sands, checking the inflow performance relationship into of the hydrocarbon into the well, and checking the vertical lift performance of hydrocarbons through the tubing. So all that design would have been done. We'll be talking extensively on that on other presentations. So here we've drilled through the reservoir. In this completion, we've decided to run a 7-inch liner. Now, the 7-inch liner is meant to provide structural isolation for for the hydrocarbon sand that we plan to complete. And after that is done, we will displace the well to, perhaps, I mean, here it's mud, but after having the liner run, you can displace the well to brine. And note, it's not just going to be any brine. The brine would have been thoroughly filtered, the total suspended solids checked, the nephrometric turbidity units of the brine checked. That why is this done? So that when we perforate these sands, we will not have solids in the brine system that will go plug up the reservoirs. So we ensure that that is done, properly sieved, before we go ahead to perforate the well. So this is just one scenario. Having liner in place, um, cementing the liner in place, then perforating through the sands. Another type of completion is, once you have the hole fully drilled, you have you've drilled to the reservoir sands. That's my cursor. You've drilled to the reservoir sands, and instead of running the liner, you have decided that you're just going to be running production screens. And after that is done, you go ahead to run your upper completion equipment. Um, like I said, your upper completion equipment would have been fully designed like your lower completion equipment. The lower completion equipment is designed to ensure inflow performance into the well bore. Then the upper completion equipment is designed properly to ensure the vertical lift out of the well bore. Now it's designed through the life of the well to ensure that the reservoir pressure is able to get reservoir into the well bore and also provide that required lift to surface. So after you have your completion, up here shows the hanger, the top part of the well, and here shows the bottom part of the well where you have the packer that will be straddling, that will be that will be suspending the tubing string. uh then finally, after that is done, it's you've run that down, we've hung that up, we've landed the well, we've hung the well up. Then we will now take away the bill, flange up the tubing spool to the Christmas tree. So the Christmas tree is pretty much just like a tap. I mean, controlling the flow of the well. You have different valves. You have your production valves. You have your swaps. When you want to close in the well, you have the well closed in. When you want to intervene the well, you close up from the swab and get into the well. So all the valves have pretty much the work that they do and how you use them to control the well bore. So after that is done, this is the well. After the rig has been rigged down and the well handed over. So these are pretty much the books that we reference, and we do thank you very much for listening to us. We appreciate your questions, we appreciate your comments, and we will want you to subscribe, like, follow us on the social media platforms. And once again, thank you very much for joining on this presentation. We hope to see you again in subsequent um, slides and deliveries that we'll be sharing on this platform. Thank you very much. Bye for now.